Hi everyone, this video goes over the intro to circles. Alright, so the first page of the circles packet just goes over parts of circles. So the first definition says any line that connects 2 points on a circle. So you can throw it on any 2 points wherever you want them to be. Let's call these two my points. If you connect them, that is called a chord. We also have created an arc right here. This is called an arc of a circle. It's just like a portion of the outside of the circle. Specifically, the next one talks about the chord that specifically connects one side of the circle to the other, and it passes through the center. So if we draw in the center of the circle, a chord that specifically connects one side of the circle, doesn't matter where, through the center to the other side. This is the whole distance of the circle from at its largest points. This is called the diameter. And then half the distance across the circle, which connects the center to a point on the circle. So here's a center. Pick any point on the circle. Maybe you pick right there. From there to there, this is called the radius. So let's investigate. So what are some angles formed by 2 radii? So 2 radii, like AO is a radius because it's half of the distance, the full way through the center of the circle, half the diameter. And OC is also a radius, so these two things are equal to each other. And if so, you've created a central angle. We call it a central angle because it literally goes through the center, central. Something about this is we say that it intercepts an arc. So this angle AOC that we created intercepts an arc on the outside of the circle. So take wherever the first point of your angle is and the last point of your angle, when you connect those together, we call that the intercepted arc. This intercepted arc can be written, so let me write this down. An arc is just a portion of the circumference. The circumference is just the whole outside of a circle. Okay. The intercepted arc is specifically the arc created from the endpoints of an angle. And the notation for an arc is, so like we know an angle notation is that angle symbol. So for an arc, like if we were talking about arc AC, we would write down AC with a curved line over it. Or if we wanted to know the measure of AC, we could do measure of AC. And right now we're going to talk about like degrees. So if we have this situation where we have a central angle, say this angle is like 50 degrees. That means the arc is also represented by 50 degrees. So we say that the angle and the arc are equal to each other. So I'm going to write measure of angle AOC is going to be equal to measure of the arc AC. So the central angle equals the intercepted arc. So the arc that its endpoints create. Now, if we have a different scenario where we have 2 chords and we're creating an angle from 2 chords, the starting and endpoints still can create the intercepted arc. So AC is still our intercepted arc that we're talking about. But you can tell, like imagine like these are rubber bands, right? and you take these rubber bands and you pull them back farther, you're going to make an angle that's smaller. So if this was still 50, like in the previous example, this is not going to be 50 anymore. It's clearly a smaller angle than that one is. Inscribed angles are actually half of the intercepted arcs. So if that was 50, then this is going to be 25. Right. So inscribed angle is half of the intercepted arc. I'm just going to put arc, half of the arc. So measure of angle ABC is half of the arc AC. The next one is kind of a take on this one. It says 1 chord and 1 diameter. But from up here, a diameter is just a chord that specifically happens to run through the center. So if we have an angle inscribed by a semicircle, so say we have this inscribed angle, and in the middle we have this diameter here, okay? See what's happening. We've got an intercepted arc that looks like this. So this angle here, and you'll notice it's already denoted with a 90-degree symbol, but it starts at A and ends at C. This is my intercepted arc. How big is this? This is half the circle. What's half of a circle? 180. So this pink arc is 180. So that makes this inscribed angle that's formed from like a little triangle from the diameter, that the end points are the end points of a diameter. This makes a 90-degree angle because the angle is always half of the arc if it's an inscribed angle. So I could be writing the exact same thing. And in this case, the angle is always going to be 90 degrees. For some reason, the Regents like loves this one. Parallel chords. This might seem intuitive, but like say AB and CD are parallel to each other, and it would be denoted like just like normal. That means that these arcs from A to C and from B to D, these intercepted arcs, they have to be equal to each other. So parallel chords create equal arcs. So we'd say like the measure of arc AC is equal to the measure of arc BD. All right, let's try some practice with this. So the first practice you're going to see is with central angles. So central angles are the ones that are the same as the arc. Okay, so let's read number 1. It says angle BOC is 80. So let's make sure that's labeled. BO, this is O. That's O, supposed to be O right here. That's the center. BOC is 80. Perfect, we've got that. COD is 60. COD 60, got that. Okay, arc BC is supposed to equal arc AE. Arc BC and arc AE are equal. I know that there's a bunch of questions here, but like this is telling me that if this is 80, then this is going to be 80. So let's just fill that in. And the diameter AD passes through the center. So AD is a diameter, so that splits it in half, like 180, 180. From here, without even looking at these questions, we can fill in what's going on. Like if this is half the circle, then this angle right here, EOD, that's 100. I know that the O is in the way, but. And this over here is also supposed to be 180. 80 plus 60 is 140. 140 minus, or 180 minus 140 is 40. Now, what these central angles mean is that any of these arcs are equal to these angles. So if this is 80, this is 80. If this is 40, 40. 80, 100, 60. So now we have everything filled in and we can answer these questions. The first one is AOB, so let's highlight that. A, O, O is the center, remember, AOB is this one, so that's our 40. AOE, A, O is our center, E, so 80. DOE, D, O is our center, E, that's his 100. These are all of the angles. Now notice the shift in notation. So this is the arcs. These are the outside. Some of them have 2 letters and some of them have 3, so we'll talk about what that means as well. So CD, arc CD is the outside of the circle. So CD is here, and that's just 60. AB is just another 40. Now, if you have 3 letters, you have to go in the order that it says. So B, C, D means you have to start at B, then go to C, then go to D. You're gonna hit C before you hit D. So if you start at B and then go to C, you have to go to the right, B, then to C, then to D. That's the angle, or the arc that we're talking about. So this encompasses from 80 all the way to the end of the one that is 60, so 80 plus 60 is 140. So this is going to be 140. Same thing with CDE. So let's make sure we go from C to D to E. So starting here and going all the way around, ending there. 60 and 100, so 160. And then the last one, let me grab another color, CDB. C first, then D, so I gotta go this way, then B. B's pretty far, so all the way around. So basically everything but 80. So you could either add all of these up, or you could just take 80 away from 360, since 360 is a full circle. 360 minus 80, (360 minus 80 is 280. So if you have to make a note somewhere like full circle is 360, that's useful information. All right, number 2 is more like an algebra version, but still, this is supposed to be the center O of this circle. And angle AOC and COB are supplementary. AOC is this one, and BOC is this one. They're supposed to be supplementary. Supplementary means what? They add up to 180. So AOC is supposed to be 2x. Here's 2x. COB is x plus 90. Those are supplementary. Without even reading any further, I know I can set those together to equal 180. But before I actually solve, let's read the rest so we don't forget. Angle AOD is 3x plus 10. AOD is 3x plus 10. I guess we'll use that later. So let's solve this equation. Combine like terms, 2x and x. So 3x plus 90 is 180. And then we'll solve. So minus 90 minus 90. 3x equals 90. Divide by 3. So x is 30. So if x is 30, let's see what we can fill in. 2x is 2 times 30, so 60. X plus 90 is 30 plus 90, which is 120. 3x plus 10 is 3 times 30, which is 90, plus 10, which is 100. Now, if you check out what we have so far, we've got 180 over here, which means we need 180 over here. Just to finish this off before we actually do all this stuff, I know that 100 plus 80 is going to give me 180, so that's my full circle. Now I can just make the adjustment for the arcs on the outside, making sure they're the same. So now let's see what we have. AOC, we already figured that out, 60. COB is 120. AOD, 100. DOB DOB is 80. All right, now we're getting into arcs. So we're talking about the outside of the circle now. Arc AB, A all the way to B. Doesn't matter which way you go in this case because it's still half the circle. Half the circle is 180. BC, B to C is just 120. Now we have to pay attention to order. CDB. So C first, then I gotta hit D, so I gotta go this way. So C all the way to D, and then to B. So basically everything besides 120. So you can add these up, or you can just take 120 away from 360. 360 minus 120 is 240, so 240. AD is the next one. Arc AD is here, so 100. Arc DB is just this part, so 80. ADC, here's another one with 3, so let's ADC, A to D, all the way to C. Gotta go in order. So basically everything besides 60. So if a full circle is 360, then this is gonna be 300. BCD, here's another one. B to C, all the way to D. Everything besides this 80. So 360 minus 80 is 280. Next one, ACD. AC all the way to D. So AAC to D, everything besides this 100. 360 minus 100 is 260. BAC, so like you want to go like this, but you're going around the circle. That's what the arc means. B to A, so you got to do 80, 100, and 60. So 80 and 100 is 180. 180 plus another 60 is 240. Or you could just take away 120 from 360. DAC, so D to A to C, it's just this piece right here, so 160. And then DBC, D to B to C. 80 and 120 is 200. All right, so that's central angles when the angles all are in the middle. They're connected to the center. Now, if they're inscribed angles, you might not necessarily see the center, like in this diagram. You're gonna see angles that are attached to like kind of the outside of the circle. So in number 3, angle B is 40. So here is 40. And then AEB is 102, right? Remember the vertex is that letter in the middle. So this is gonna be 102, E. Now let's see what we can figure out before we do all of this stuff. So what shape do I see right here? I've got a triangle. So somewhere I know that a triangle is 180 degrees. Right now I have 102 and 40 degrees. And that's going to be 142. If I take away 142 from 180, I get 38. So I'm dealing with this scenario where I have 38, 40, and 102. Now, these are vertical angles, so I know this is also 102. The question is, I don't know what these are. If these are parallel, then I can use the Z, but I don't see anything here about things being parallel. And man, our 38 and 40 are like pretty close to each other. So the angles are gonna look pretty similar to each other regardless. So let's look at the inscribed angles. So if I look at this inscribed angle, like with this 38, say, let me highlight it, the one that makes this 38 here. This 38 intercepts the arc BC since it starts at B and then the angle ends at C. So what we know is that the angle is half of the arc. So 38 is half of what number? Basically, what's 38 times 2? So 38 times 2 is 76. So over here, maybe you're right, 38 times 2. So this is going to be 76. Now wait, do you see another angle that starts at B and ends at C, but doesn't have A in the middle? So if we follow the other line that I didn't highlight, we have this angle right here, BDC. This one also intercepts 76. So to create the angle D, I'm going to take half of 76. I know that half of 76 is 38 basically because I just did that. So this is actually 38 over here. I know that's pretty small. Then using that same triangle as 180 math, this one's got to be 40. So are these lines parallel? No, because the Z does not work out. So remember, the alternate interior angle Z only works if they're parallel. So my 38 is here and my 40 is here. And again, that's because this 38 intercepted arc BC, which created also the angle BDC. So if you have two angles that intercept the same arc, they've got to be equal to each other, 38 and 38. I could use this same logic on the other side of the triangle as well, because like say I look at the 40 instead of the 38. Now I have this angle that opens out like that, and it intercepts arc AD like this. So again, AD is going to be double this arc right here. 40 times 2, that's 80. Now, again, we have another angle that starts at A and ends at D, and it's over here, ACD. That's also 40. So these two angles are equal to each other because they intercept the same arc. So watch out for angles that start and end in the same place. They might have some different intermediate point, but those are going to be equal to each other. So knowing that, let's answer these questions. We know angle A is 38. Arc BC, 76. Arc AD is 80. Angle D is 38, that's that one. And angle C is 40. They're all connected to each other. Number 4, triangle ABC is inscribed in a circle. Again, here I don't have the center. I don't have these angles coming off the center. This is where we're going to use that half scenario. So the angle is always half of the arc. So if I use this 88 as an example, 88, I need to do half of 88 to figure out the angle that was created. This arc starts at A and ends at C. So we're looking for an angle that starts at A, bops down to B, and then ends at C. So 88 divided by 2 is going to be 44. Now I have this whole triangle equals 180 scenario again. So 44 plus 80 is 124. And then if I take that away from 180, I'll have 56. So that'll be my remaining angle. Now if I use my inscribed angles, my angles are half of the arc. So the angles are the things that are smaller. So here's an angle of 56, right? It starts at A and ends at B. So the intercepted arc is AB. So this is the arc we care about that goes with 56. All right, so as it goes out, it gets bigger. So 56 times 2 is going to give us this outside part. 56 times 2 is 112. So this will be 112. Now, if we use the same logic, the only thing we don't have is BC. Well, how can we create BC? Start at B, find an angle that starts at B and ends at C. So there's this one here, the 80-degree angle. And we care about this one, and it will intercept this arc. So again, like this 80 is kind of like shining a light on this arc. It's getting bigger. 80 times 2 is going to be 160. And you can double check that this makes sense because these angles out here should add up to 360, which also should reflect the fact that we have 180 degrees in a triangle. If I'm doubling all of the angles in a triangle, I should get 360 since double 180 is 360. So let's fill out this side. Arc BC is 160. Angle B was 44. Angle C was 56. And AB was 112. All right, more inscribed angles again because they don't hit the center. So fill in the blanks. Angle ABC is the same as which one? Let's highlight ABC. ABC goes this way. This is angle ABC. So we know that ABC starts at A, ends at C. So I need another angle that starts at A and ends at C, but it doesn't hit B. So look here. Do you see another place we could go? We could go to D. ADC. They are both inscribed angles and they intercept the same arc. They both intercept AC. So we'll do ADC this time. Again, notice the thing about these. They start at A, they end at C, they have that different intermediate point right in the middle, the vertex. Let's look at the reverse version of this, BAD. BAD is this angle here. Starts at B, ends at D. It's got A in the middle. So BAD is going to be the same thing as another angle that starts at B and ends at D. So the only other way we could go is down this purple line, BCD. Those are going to be the same. Again, start at B, end at, what did I just do? BCD, I wrote it wrong. And you know, I can easily catch my mistake, honestly, because I need it to start at B and end at D. So if it doesn't do that, then I know I wrote it wrong. Why are these arcs equal to each other? Because why are these, let me rephrase this. Why are these angles equal to each other? Because they intercept the same arc. So the green ones both intercepted BD and the purple one intercepted AC. Given the diagram at the right, name two right angles. So if my inscribed angle happens to be the starting and end points of a diameter, since this whole part is 180, half of 180 would be 90. That's how I'm going to get a right angle. So I need two angles that start at A and end at D. So let's look. We could go from A all the way to C and then to D. That would be a right angle because half of 180 is 90. Angle ACD. And we could do that. Is there another way we could go? We could go from A. Instead of all the way to C, we could go from A to B and then to D. So we have the same, again, we have the same two endpoints, so they have to be equal to each other. Angle ABD. Again, pay attention to the starting and end points. Which angle intercepts the same arc as CAD? C, this is going to be harder to envision, but CAD. So I'm looking for another angle that starts at C and ends at D. Is there another way we could go? We could go CBD, that would work. So CAD and CBD, those are equal to each other. And then if we look on the other side, which arc intercepts, or which angle intercepts the same arc as BDA? BDA starts at B and ends at A. So let's find another one that does that. Maybe BCA. Last one, if BC is parallel to AD, which arcs are equal? So BC and AD are parallel. So parallel chords create arcs that are equal in between them. So arc AB, the measure of arc AB would be the same as the measure of arc CD. All right, this is your basic intro to circles. Hope you had fun.